Dear students, welcome to my 4th class on Module 3. In this lecture video, we will discuss about the new concept Z transforms, definition of Z transforms and some standard functions of Z transforms. So first we will learn why to use Z transforms. In the Module 1, we learned about Laplace transform concepts, right? So that Laplace transform will be useful to solve the differential equation. Similarly, this Z transform also useful to solve the difference equations. And this Z transform is an essential part of an structured control system design. And also the one good thing about Z transform is, so this Z transform will be useful to write a software. Also, this Z transforms plays a significant role in communication theory, especially in signal processing. So in signal processing, the Z transforms converts a discrete time domain signal, which is a sequence of real numbers, into a complex frequency domain representation. So now we will see what is Z transform and what is the basic formula we have for Z transform. So let f of n be any sequence defined for n is equal to 0, 1, 2, 3, so on. So then Z transform of the given sequence f of n is defined by Z transform of f of n is equal to summation n from 0 to infinity f of n z power minus n. So this basic formula we will be using to prove all the standard formulas in the Z transform. So here this Z is an arbitrary complex variable. The right hand side of the above equation is a function of Z, and hence it is denoted by Z transform of f of n is equal to f of z. A small note on Z transform: the domain of the Z transform in n is equal to 0, 1, 2 and also for the bilateral Z transform is n is equal to 0 plus or minus 1 plus or minus 2 and so on we'll be using. So and also in this module we'll be discussing only about n is equal to 0, 1, 2, 3 only. So some basic formulas which is required to solve the problems in Z transform. The first formula is 1 minus x whole power minus 1, so which can be expanded like 1 plus x square plus x cube and so on. So where mod x is less than 1. Similarly 1 plus x whole power minus 1, this will be equal to 1 minus x plus x square minus x cube plus so on, where mod x is less than 1. 1 minus x whole power minus 2, this will be equal to 1 plus 2x plus 3x square plus 4x cube plus so on, where mod x is less than 1. 1 plus x whole power minus 2, this will be equal to 1 minus 2x plus 3x square minus 4x cube plus so on, where mod x is less than 1. Minus of log 1 minus x can be expanded like x plus x square by 2, x cube by 3 plus x power 4 by 4 and so on. And e power x will be expanded like 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial and so on. So some standard Z transform formulas we'll be discussing now. The first one is, so constant 1, a power n, 1 by n, 1 by n plus 1, 1 by n minus 1, 1 by n factorial, 1 by n plus 1 factorial, 1 by n plus 2, and also unit impulse function and unit step function. So for all this one, I'm going to find the Z transforms. So first one, find the Z transform of 1. So we know the basic formula of Z transform, that is Z transform of f of n is equal to summation n from 0 to infinity f of n z power minus n. So now to find Z transform of 1, in the place of f of n, I am going to replace 1. So we got Z transform of 1 is equal to summation n from 0 to infinity 1 into 1 by z whole power n. So expanding the summation, we got 1 when n is equal to 0. When n is equal to 1, we got 1 by z. When n is equal to 2, we got 1 by z whole square. When n is equal to 3, we got 1 by z whole cube and so on, where this mod of 1 by z is less than 1. And simplifying this, it will be equal to 1 by 1 minus z whole power minus 1 with the help of basic formula, with the condition 1 is less than mod z, and taking LCM over here, we'll be getting z minus 1 by z whole power minus 1 with the condition mod z is greater than 1. So finally we got Z transform of 1 is equal to z by z minus 1 with the condition mod z is greater than 1. So therefore Z transform of 1 formula is z by z minus 1. Second one, z transform of a power n. So the same basic formula we'll be using here also. So z transform of f of n is equal to summation n from 0 to infinity f of n z power minus n. So now in the place of f of n, I am going to replace a power n. So we got z transform of a power n is equal to summation n from 0 to infinity a power n into 1 by z whole power n, or summation n from 0 to infinity a by z whole power n. By expanding this summation when n is equal to 0, 1, 2, 3 and so on till infinity, we got 1 plus a by z whole square plus a by z whole cube and so on. So expanding this further, so it will be equal to 1 minus a by z whole power minus 1. By taking LCM, we got z minus a by z whole power minus 1 with the condition mod z is greater than a. So therefore z transform of a power n will be z by z minus a with the condition mod z is greater than mod a. So next one is z transform of n. So same thing here also. First take the basic formula of z transform, that is z transform of f of n is equal to summation n from 0 to infinity f of n z power minus n. So now in the place of f of n, I am going to replace n. So we got z transform of n is equal to summation n from 0 to infinity n into 1 by z whole power n. So now by replacing n is equal to 0, 1, 2, 3 till infinity, we got 0 plus 1 into 1 by z plus 2 into 1 by z whole square plus 3 into 1 by z whole cube plus 4 into 1 by z whole power 4. So from this entire equation, I will be taking 1 by z common factor. So I got 1 by z into 1 plus 2 into 1 by z plus 3 into 1 by z whole square plus 4 into 1 by z whole cube and so on. So this will be equal to 1 minus 1 by z whole power minus 2 with the condition into 1 by z. So expanding this, we got 1 by z into z minus 1 by z whole power minus 2. So it will be equal to 1 by z by z minus 1 whole square. Simplifying this, we got z transform of n is equal to z by z minus 1 whole square with the condition mod z is greater than 1. So now the next standard function is z transform of 1 by n with the condition n is greater than 0. The same basic formula will be taking here. And in the place of f of n, I am going to replace 1 by n. So we got z transform of 1 by n is equal to summation n from 1 to infinity 1 by n z power minus n. So it will be equal to summation n from 1 to infinity 1 by n 1 by z whole power n. So now expanding summation by replacing n is equal to 1 to infinity. So we got 1 by 1 into 1 by z plus 1 by 2 into 1 by z whole square plus 1 by 3 into 1 by z whole cube and so on. And simplifying this further, this will be equal to what? Minus log of 1 minus 1 by z, or minus log of z minus 1 by z by taking LCM, or log of z minus 1 by z whole power minus 1, or z transform of 1 by n will be equal to log of z by z minus 1 we can write. So next function is z transform of 1 by n plus 1. So same like a previous proofs only. So first you take the basic formulas, and in the basic formula, in the place of f of n, I will be replacing 1 by n plus 1. So z transform of 1 by n plus 1 will be equal to summation n from 0 to infinity 1 by n plus 1 z power minus n is equal to summation n from 0 to infinity 1 by n plus 1 1 by z whole power n. So expanding the summation for n is equal to 0, 1, 2, 3 till infinity, we got 1 plus 1 by 2 1 by z plus 1 by 3 1 by z whole square plus 1 by 4 1 by z whole cube. So by taking z common factor from the entire equation, so we got z into 1 by z plus 1 by 2 1 by z whole square plus 1 by 3 1 by z whole cube plus 1 by 4 1 by z whole power 4 and so on. So this will be equal to minus z log of 1 minus 1 by z. By taking LCM, we got minus z log of z minus 1 by z, or z into log of z minus 1 by z whole power minus 1. So therefore z transform of 1 by n plus 1 will be z into log of z by z minus 1 with the condition mod z is greater than 1. So next standard proof is z transform of 1 by n minus 1 with the condition n is greater than 1. So first you take the basic formula, in the place of f of n, will be replacing 1 by n minus 1. So therefore z transform of 1 by n minus 1 will be equal to summation n from 2 to infinity 1 by n minus 1 into z power minus 1 is equal to summation n from 2 to infinity 1 by n minus 1 1 by z whole power n I am taking. So now start replacing n is equal to 2 to infinity. So we got 1 by 1 1 by z whole square plus 1 by 2 1 by z whole cube plus 1 by 3 1 by z whole power 4 and so on. By taking 1 by z common factor, we got 1 by z into 1 by z plus 1 by 2 1 by z whole square plus 1 by 3 1 by z whole cube and so on. So by simplifying this we got minus 1 by z into log of 1 minus 1 by z, or minus log into z minus 1 by z, or 1 by z into log of z minus 1 by z into whole power minus 1. So by simplifying this we got z transform of 1 by n minus 1 will be equal to 1 by z into log of z by z minus 1. The condition mod z is greater than 1. So next one is z transform of 1 by n factorial. So first take the basic formula. In the place of f of n, replace 1 by n factorial. So we got z transform of 1 by n factorial is equal to summation n from 0 to infinity 1 by n factorial into z power minus n. This will be equal to what? Summation n from 0 to infinity 1 by n factorial 1 by z whole power n. Expanding summation, we got this series, and simplifying this we got z transform of 1 by n factorial is equal to e power 1 by z. Same thing here also. So same like this proof only. In the place of n, I'll be replacing n plus 1 factorial. That's it. So what will be getting? Z transform of 1 by n plus 1 factorial will be equal to summation n from 0 to infinity 1 by n plus 1 factorial into z power minus n, or summation n from 0 to infinity 1 by n plus 1 factorial into 1 by z whole power n. Expanding this summation by replacing n is equal to 0 to infinity, we got this complete series, and by simplifying this we got z transform of 1 by n plus 1 factor will be equal to z into e power 1 by z minus 1. So next is initial value theorem. The statement for the initial value theorem is z transform of f of n is equal to f of z, then small f of 0 will be equal to limit z tends to infinity f of z. So this formula will be using to solve the problems based on the initial value theorem. So next is final value theorem. The statement of the final value theorem is if z transform of f of n is equal to f of z, then limit n tends to infinity f of n will be equal to limit z tends to 1 z minus 1 into f of z is a formula for final value theorem. Okay, in the next lecture video, we'll be discussing the problems on initial value theorem and final value theorem. Thank you.